Okay, so today the topic is file management, which is Unit 6 in the study guide. We'll cover the following learning outcomes: understand the importance of the concept of file management, be familiar with file names, extensions, and operations, explain the different file access methods, understand the importance of file backups, and explain the NTFS file system. Okay, so a file, it's a term. Most of the operating system terms are actually coming from the real world. So if you're talking about files, it's files or things that existed way before operating systems even existed. The only difference is that operating systems had to make this concept more electronic. Okay, so when you use an application to do work, for example, write a paper, make a spreadsheet, or draw a picture, the work is stored in RAM. Okay, so firstly, it's stored in RAM, which is a danger of being lost if the power goes off. RAM is volatile. Okay, so when you open up a program on your computer and opening up a file, maybe you're doing an assignment and you're using Microsoft Word. So for as long as you didn't save that file, it's going to be working from the memory. Then load shedding hits. What happened? What's going to happen is that you're going to lose that file, okay, because you didn't save. So for as long as you didn't save it, it becomes I'd call it a temporary file. Okay. And then when you actually save it, what happens? It is copied to a secondary storage device like a hard drive or a flash drive. It is saved as a file with the name, extension, time, date, and size. The only thing that you as the user may need to specify here is the name of the file. Okay, so when you're saving, the only thing you can change is the name of the file. Yes, here and there, depending on the type of file, you may also change the extension in real time, but most of the time when you start to fidget with the extension, you end up creating or causing the file to be corrupt. And timestamps, dates, and the size of the file, all of those are appended by the operating system, okay? So the extension, if there is one, is at the right end of the name with the period before it. Like file, example is file1.abc. So the extension in this particular case will be .abc and the file name would be file1, okay? So files ensure long-term existence, okay? So they are saved onto a secondary storage like a flash drive and a hard drive, and they exist for a longer period. They're permanent until you decide to delete them. And also files are shareable between processes. So multiple programs can have access to the same file. And we've spoken about this, and we said for this to happen successfully, there has to be proper protection so that the one process does not delete the file while the other process is reading from the file. The other thing is while we're discussing files in this particular study unit, it's used to define two concepts. Okay, so files as we know them on our computer, we create an assignment or an MP3 song or a movie, whatever is on your desktop or on your computer is considered as a file, okay? But also files can be you referring to database files that we use to store data about things, okay? So it's not only what you normally see on your desktop and folders in your computer, it's also referring to database files. So the concept of file management. The development and maintenance of an organized and meaningful file system. The operating system provides an organizational structure to the computer's data and programs, hierarchical structure of directories. So when you're talking about file management, it's an organized and meaningful way of organizing files and managing files, okay, on a computer system. And this is done through what we call folders or directories. Okay, so we have, let's assume we have two. So we have a hard drive that is C drive, okay? We have a C drive, which is root. Then we have a folder, college, and then we have a Windows folder. In the college folder, we store files like fall 2006, and then we have CS 101, CS 215, CS 221, and then inside CS 101, we have a file located there. So the main thing being demonstrated here is that files can reside within a hierarchy of directories. So you can have a directory within a directory. That's just the structure of the whole concept of file management. And the reason why these folders or how can I put it, merged or integrated into other folders, okay? The reason why we have SIPE directory structures is for us to better manage or organize these files, okay? Some people in their computers, you find multiple folders. The reason for this is it helps them better understand or better be able to manage and locate the particular files that they're looking for. So you put a folder there for Demelin, a folder for IT, a folder for networks, system software, information systems programming. Inside those folders, you have a folder for assignment 1, a folder for assignment 2, okay? A folder for whatever, past papers, whatever. So everything that you are doing is for you to be able to better manage your files, and it makes sense to you when you are browsing this hierarchy and you're able to locate things more conveniently. Definitely, this is more efficient than how files were stored back in the day using those physical cabinets. The disadvantage of physical cabinets, number one, is that files may be lost, easily stolen. Some of them can be locked. When I refer to a physical cabinet, you can see on the bottom right-hand corner of the screen, this is not an electronic means of storing files. It's actually storing physical files. So this is not secure if you don't lock it up. Even if you lock it up, you can still lose files if there's a flood in the building or from the sprinkler system. It damages everything. Also, when you have to search, it is a time-consuming thing to do when you have to search or locate a particular student's file when they are stored in actual physical cabinets. So through the operating system, using directories, and the operating system also has Explorer, which is an advanced feature of locating paths or paths to files that you are looking for. Okay, so it brings that convenience. So when it comes to electronic storage of files, we have the logical versus the physical view. The physical view is the blocks of secondary storage assigned to storing of files, okay? So it's the disk blocks, physical view. Then we have the logical view. So the logical view is what the end user actually sees, which doesn't necessarily represent how everything is in the physical view. Okay, so the logical view is what we see with our eyes, but it doesn't represent the structure at the physical level. So we have our files, which could be our shortcuts on our desktop, MP3s, and so forth. Those are all files, and they form part of the logical structure. Then we have folders. So shortcuts are found on the desktop directory or the desktop folder. Then we also have volumes. Okay, so a hard drive at the physical view is one physical device, but that one physical device can be divided into multiple volumes. Okay, and another term that we use to refer to a volume is a partition. So each volume will be assigned a unique virtualized drive number. So maybe there's volume E, there's volume D, there's volume C, there's volume A, and so forth, okay? So one physical hard drive can be virtualized into multiple volumes, and that forms part of the logical view. And I'm saying this because it does not represent the physical view. The physical view is that it's one physical hard disk. Okay, so file names and file extensions. Okay, you must adhere to file naming conventions when saving files. Case sensitivity, uppercase and lowercase are different. In Windows, you can get away with this, okay? But in Linux, there is case sensitivity. And the reason for that is because remember that Linux makes use of the terminal. So you may make use of the terminal to access directories and files. But in Windows, everything we do through the graphical user interface. So you don't have to worry about how the operating system may be interpreting a file name. So case sensitivity is not an issue when it comes to Windows, but Unix-based Linux systems. So if you are saying a folder is called uppercase ABC, okay, or a file is called uppercase ABC, then now you are typing in the terminal and you put lowercase ABC to make reference to that particular file in the terminal if you're on a Linux system. There's going to be a mismatch because then it assumes that you're making reference to a different file. So hence, case sensitivity is valid in file names for Linux. In Windows, it's not really much of a problem. So you can have uppercase, a mix of uppercase and lowercase, and so forth. Even when you're making reference to it, it doesn't matter. So in Windows, the maximum length of characters you can use to name a file is 260 characters. Spaces allowed. Be careful if you're using multiple spaces. You can see the difference between 2 spaces and 3 spaces. Okay, so you see when it comes to Linux, you're going to face this problem. So you have, let's say, a file that is something like, the file name is something like, let's say, hello space and then world. Okay, so if this was a file name, in terms of Linux, when you are using a terminal, it's going to break the syntax because there is a space in between. Okay, so in Windows, we don't make use of a terminal to access files and folders. So it's not a problem. You can have spaces in between, but you have to consider this fact when it comes to Linux, that when you have spaces between the naming conventions of your files and folders, it means when you're making reference to them on the terminal, you're going to need to what? As we do in programming, you're going to need to double quote them so that the operating system does not get confused. Okay, so very important that you take into consideration that issue of spaces. Also, characters allowed. What kind of characters are allowed? Okay, if I put hello world and I put, let's say, I put a star in between. I put a star in between the hello and the world. So this becomes my file name. Even in Windows, it rejects certain characters in your file names and in your folder names. That's because those characters are reserved for the operating system. So back to the example of Linux. So you put a star here in between hello and world. Now, you'd find that most of the time you find that this star character is already used by the syntax in the operating system as a wildcard to target multiple extensions. Okay, so it doesn't matter if this was a let's say .png or a .jpg or whatever. In terms of wildcards using a star, a wildcard can be used to target all the file name extensions. So that character, the star character, may be used up already by the operating system. So when you start to put it as part of your file names, you are actually confusing the terminal. Okay, so that's why certain characters are not allowed in naming of folders and files. File extensions provide clues to different file contents, and OS uses extensions to know which application created the file and internal format of the file. So certain externals are certain extensions are universal, which means they can be accessed by multiple applications, like something like a PNG, .jpg, .mp3. All of those are common or universal to most operating systems. So anybody can build an application to access or open those files or media player. But certain extensions are reserved for particular applications. So you won't use just any ordinary application to open these files. You need a specific one. Okay, you've noticed this in Microsoft.x. You can't open up a Word document if you don't have Microsoft Word, but you can open up a text file on your computer because the text.txt format is a universal format when it comes to operating systems. It's not owned by any particular application. So some of the common extensions that we know of or may have seen when it comes to Microsoft Office, we have Microsoft Word uses earlier version .doc, and then there's also .doc. X stands for extended. Same thing applies to Excel. There's .xls and .xlsx, again for extended. Then same thing applies with PowerPoint. There's .ppt and .ppt extended. Okay, so these are the common extensions used by Microsoft Office. There are other ones as well. And then there's also audio files. We know these are all audio encoding formats, AAC, MP3, you may be familiar with, which is actually a standard. We have .wave and .wma. For video, we have .avi, .mov, then .mp4, .wmv, and for images, common as GIF, your favorite one that you always post in the WhatsApp groups, .gif, .jpg, .bmp, okay? And there are other ones as well that we are familiar with, PDF, for programs running on Microsoft Windows, we have .executable, okay? And this does not apply to Unix or Windows because it doesn't use executable files. It uses a different format for opening programs. And then we also have compressed file extensions, which include .rar and .zip file extensions. So what are the different things that can be done with files? What are the different operations? So we can create new files. Okay, when it doesn't exist, we can create it from scratch. We can delete files. So it involves erasing or removing a file from a particular volume or from a computer, and the file will be destroyed permanently. There's no other way, or there is a way of recovering it, but it may not work for every type of file, okay? Files like text files can be easily recovered, but certain file formats, once you delete them, then you run into a problem. Once you recover them, then the files are corrupt. Open files, you may open files as well. Many activities can be performed by the process. Close files refers to closing of the process or of the file. No activities will take place, and then you can write, which means you're updating or modifying a file. So these are the different things that you can do with files on a computer. So we have also then the file system. So the file system defines rules or guidelines to how files are stored and retrieved, saved and retrieved on a particular computer. There are different types of file systems. They vary based on operating systems. So MacBooks or Mac OS will use its own type of file system. Windows will use its own file system, which is called NTFS. Linux is compatible with NTFS, so it's not a problem. So it doesn't have its own specific one. It can run easily on NTFS-based volumes or partitions. Database file structures. Okay, so we spoke about files in terms of desktop files, MP3s, PDFs, doc files on a desktop and folders, but there's also database files, okay? And when we're referring to a database file structure, the four main terms of a file structure are a field. A field, another name for this would be a column, okay? So it refers to the basic elements of data. A single field can hold a single value. Example of a field is a customer's first name. Okay, so field, basic element, one data element, which is example of a customer's first name. And then we have a record. A record is a grouping of fields or multiple columns that form data about the particular entity that we're storing in our database. So a record is a combination of multiple fields. Okay, and then a file is the actual database file that contains multiple tables with multiple records in them, which are made up of tiny building blocks called fields. I'll show you what this actually looks like practically later on. So a file is a collection of similar records. Okay, so a file is a collection of records, and a record is a collection of fields. Users can treat a file as a single unit. Users can create files and delete them. Access control can be assigned to files. Another term that we use to refer to files in terms of database terms or database principles is tables. Okay, so we have tables, records, and fields. And then the database itself is the actual file that stores everything, which resides in the, which is actually created onto the secondary hard disk. So stuff like tables, records, and fields, they are logical. You see them with your eyes, but the actual data is the database file stored on a hard drive as how you store a normal file like an MP3, and it does not represent how the data actually looks logically in terms of tables. Okay, you won't be able to, if you're looking at it from a physical perspective, you'll just see the file, which is the database file. You won't see the tables, you won't see the records, you won't see the fields. So all of these components are more logical because you only see them when you're opening up the database using a special software, which I'll show you now. So file sharing, two issues arise when allowing files to be shared amongst several users. How are you going to control access rights? How are you going to manage simultaneous access? If two users are trying to make changes to the same pieces of data, how are you going to ensure concurrency? So these are some of the challenges that you're going to face if you allow file sharing on your system. Okay, one of the ways to manage simultaneous access is through a locking mechanism, where as much as the users may need to make changes to the same file, but when user one is accessing it, it will be locked for that duration. Then when user two or a different process tries to access that file, then it will be prevented from doing so. And you may have seen this in a lot of places, okay? Even in Microsoft Word, it makes use of this same concept to initiate simultaneous access. If you have a Microsoft Word file open and you type in your assignment, then you go to the folder where you're actually working from and you try to delete that. It will prevent you from doing so because simultaneous access, okay, one is editing and one wants to create a different operation, which is delete. So it will be prevented from doing so. The file will be locked while it's still open. Once you close it, then it will allow you to initiate your operation, okay? So there is that locking mechanism. It's locked for exclusive use for a particular process. And then once the process is done with it, it unlocks it and then the next process can access that file. In terms of access rights, there are different types of access rights that can be given to users. You can even give access rights to groups. So an owner of a file on a computer is the administrator. It's the person who created the file. It's the person who put it on the desktop, okay? So the administrator has full rights and is the one that grants access to the users to access a particular file, okay? So then you can also, as the owner, give users to, give rights or access rights to specific users on a computer. So you can say, okay, here's my sibling, my brother, my sister, and or my cousin. I'm giving them access rights, specific users, okay? Or you can have a group of users, maybe a group called family and a group called friends, okay? Where you don't give the same access rights to your friends that you would give to your family. And then you can give access to all users, no matter who the person is. If they're logging into the computer, they have full control of it's a public file, okay? Anybody can have access to it. Something like a recycle bin on a desktop. That is something that would be an example of all access control. Anybody, no matter who you are on the computer, you have access to that recycle bin, okay? So then we have a file management system, okay? So let's assume here that we are talking about a database file management system, okay? I just wanna show you guys something quickly. Okay, so here we have a software, and this software is in front of me now, is called Microsoft Access. So it is a file management system for what? For database files. So with this system, we are able to do multiple things. We are able to create new database files. We are able to make changes to existing database files, which means adding new tables, adding rows, adding columns, and so forth. Okay, so this is a typical file management system, and the beauty of this is that you eliminate this thing of having different applications in our organization to access these data structures. It means everybody who wants to access this database file just has to have Microsoft Access. It's universal, a universal application that we all use in the organization, and you're able to do the same things with it, okay? So you can see here that we have a database table, okay? A database table or a file, a database file. And the database file consists of multiple fields. What are the fields? There's an ID field, there's a first name field, there's a last name field, email address, and so forth. So all of these are basic elements or basic building blocks, and they are referred to as fields. Okay, so far in this database table, we only have one record or one row, and the one entry there is of John Wick, is the particular person that we are storing data about. Okay, so I want us to just pay attention to the first one, to the first field in our database. So usually the first field in our database is it is reserved for what we call key values. Okay, so key values are auto incrementing because you can see now I'm just inserting default data, that I didn't insert anything in the ID field. It auto incremented by itself. Okay, so we say the key value must by all means be unique, must be auto incrementing. Okay, so you don't insert it as the user, it auto increments itself. So it's usually the first field in any database, and it's referred to as the key value. Why is it there? For us to be able to access specific records if we're looking for these records, okay? So we're going to be making reference to all of these concepts, and hence I showed you that on Microsoft Access. So Microsoft Access then can be called a database management system, or in generic terms, a file management system. The main objectives of file management systems are meet the data management needs of users, performance optimization, okay? So we can look at how fast are these records being retrieved when we run a query or when we try to access them, and we can optimize and do things, write better access code to be able to optimize the whole retrieving of those records. To provide valid data, okay, reduce inconsistencies, provide valid data, allow various storage devices to store data, provide interface to users. As you saw, the Access is a good interface and people are able to make changes, provide input-output support for a variety of storage device types, and give support to multiple users, okay? So you can see that with this file management system, because we are all as these users in a multi-user system, we're all accessing the same database file. So by using the same file management system, we ensure consistency. We ensure that we implement access rights in one location and so forth, instead of having all of these things segregated to different applications. File organization and access. Okay, so there are different access methods which are used to access files from secondary storage. Okay, file organization refers to the structuring of data or records in a file. Access control can be assigned to these files. Okay, so file organization characteristics look at ways at which we can efficiently access specific record entries in a database table and optimizing time. Okay, you can see here the record highlighted. There's multiple records there. So if we're looking for the specific one highlighted in red, in terms of file organization and access methods, it's defining ways at which we can efficiently reducing the amount of time taken to access those records. And there are these types of access methods. We have the pile, we have the sequential file access method, we have the index sequential file access method, we have the index file, and then we have the hash method. Okay, so a typical program will be structured this way. We have the actual user program with the user interface. Then we have the second layer, which is the different access methods, which are listed here on the left-hand side. And then we also have our logical input output, okay, which defines how the records are accessed logically, input output in terms of retrieving the records from secondary storage. Then we have our basic input output supervisor, which is supervising the input output requests as they're coming from the secondary data sources. And then we have the basic file system, which defines access rights and permissions. And then we have our device drivers, okay, which these are used to communicate with the operating system so that the operating system is able to recognize the different peripheral devices, okay? So we are going to be paying attention to this layer, which has the access methods, the pile, sequential, indexed, sequential, the indexed, and the hashed, and how they vary, okay? So the first one is the pile. And when you just think about the term pile in generic terms, what is a pile? It's a pile of things. When you're thinking about a pile of things, it's just stacked together. There isn't a formalized structure, and things are not equal. So when it comes to piles, data is stored in variable blocks. I just want to return again to access. So if you're looking at access, all of these fields or columns are of fixed length. Okay, they equal in length in terms of the amount of space they take up, they equal in length. But when it comes to a pile storage, we're storing variable blocks length of fields, and even the fields, they are different in terms of the names that they have. Okay, so you can see here that all of the fields in this particular table, which is students, okay, they're consistent, which means all the users we insert as records, they will have the same, more or less the same fields. But in terms of a pile file structure, there's variable blocks, which means the fields are not equal sizes, but also the fields do not have the same names, and the names are not in the same order. Okay, so it's just a pile of data stored in one place. right? And it's the most simplest form, but access can be a bit tricky because then you're going to have to make use of some sort of sophisticated searching mechanisms to search this unstructured data. When it comes to indexed files, so we have the pile. So we have the pile, we have the indexed file. So in terms of indexes, okay, before I talk about the index file, I just want to talk about the sequential file first. So sequential access means that we make use of a key value, an ID, to access records. Okay, so you can see here there's a student ID, for each entry, which means when these records are being accessed from the secondary data, they'll be accessed based on that order, based on these key values or based on the primary key. Some people, when they design databases, the keys that they put are not unique values, which can cause a problem in terms of sequential access, but nonetheless, the operating system will still follow a sequence where it's possible. So if it's ID A, ID B, ID C, it'll follow that sequence, whatever it can view as a chronological order. Okay, it may use A to Z, 1 to 9. Okay, whatever is a chronological order in a key value, it will use that to access the data in that particular order. So hence, we refer to it as a sequential access, okay? And in contrast, we have indexed file access. So in index, we'll have indexes, and indexes are not created, okay, are not created by the user, or they're not created by the database administrator. They are created by the file management system. They are appended to each rows of data. So even if a user creates a database but does not create an ID field or a key value field for the database database table, still the file management system will be able to access the records. How? Through an index. Okay, indexes always start from 0. Sorry, this will be the 0, then it'll be 1, then it'll be 2, and so forth. And it makes it easier to access these files without the presence of a key value. Okay, so then we also have sequential, which is more reliant on the key itself. Then we have indexed sequential file, which means there's both the presence of a ID or key value, and there's also the presence of an index. Okay, and this is like a backup mechanism. So when the operating system cannot make sense of the ID that you are putting, maybe it's using duplicate values, then it will sort of default to the indexes. And then we also have the hashed access method, and this is mostly used by directories on a computer. Okay, so you know that the operating system would have a difficulty if you are using the same name to name a particular folder, because there's going to be conflict. However, there's also a hash, and a hash is it's like a encrypted kind of globally unique generated long string, and it serves the same purpose as an index in the sense that we can uniquely and directly access a specific file or data on a computer using that hash, because the hashes will not be the same. Number one, there's no possibility for them being the same because they are created through a cipher on the operating system. So there's no way they can be the same. Also, the indexes, there's no way they can be the same because they are created by the database management file. So the hashes are normally used by directories, but we find indexes being used in a database management system as well, such as Access. So then we have also the different file permissions that we can assign to files. So a file can have none, No permissions. If a person has no permissions at all, then they can do nothing. They can't read the file, okay? If they have permissions, which is knowledge permissions, they can view the properties of a file, not the actual file itself, but the properties of a file. They know it exists, they can view its properties, and they can also see which particular users have been given rights to access that file. If you are given execution permissions, it means you are able to load and execute a program. So you're able to open up Adobe and so forth. Reading enables the user to read a file, okay? So the reader can what? Can read a file but cannot delete it. So if you have only read-only permissions, that's all you can do. You cannot modify. Appending, okay? It allows the user to add more data. Appending does not allow the user to modify or delete the content of the file. So I can append, I can add an entry like you saw in my database table. I can add the next row, but I cannot now change the ID or delete the first name field or delete the last name field. My only permissions is appending, adding new rows. Updating allows the user to delete and modify. So I can delete and modify columns, delete and modify rows as much as I want, okay? And changing protection enables the user to change the access rights granted to other users, okay? So I have, as the owner of the file, changing protection permissions where I can ensure that I can change the permissions of other users for this particular file because I am the owner for it. And then you also have delete permissions. The user can delete the file or a folder. So these are more specific to the database side of things, permissions that we assign to database file. Hence, we talk about appending new data, appending new rows. So when it comes to files, we have to ensure fault tolerance because disaster does strike and things get damaged in between and so forth. So we need to ensure that data is not lost by creating backups, okay? And backups can be done manually. So even yourself copying a folder from your computer into your external hard drive, that is a manual backup, and you're doing that for fault tolerance. In the event that your computer crashes, you still have access to it. Then we have full or incremental backup. Okay, so full backup, I'm backing up everything. Every single time I'm doing a backup, I'm backing up everything on the computer. Incremental backup, we're only backing up stuff that has changed since our last full backup. And that's the difference between the two types of backups, okay? Most organizations that are running mission critical systems would have to implement automatic backups for fault tolerance. Something like a bank won't do they will do a periodic backup, which is automated, maybe after every hour or whatever period the data is backed up on different hard drives. And fault tolerance again, so file backup, very important. Recovery methods and the different software we can use to recover lost data, okay? And transaction logging. The reason why we have transaction logs on databases is every single time we successfully insert a new or append a new data row within our database, a transaction is logged in a transaction log. And the transaction log is to ensure that either the data was fully inserted or not. So there's no in between. There's no parts of the record. Only certain fields were inserted successfully. No, the only time that this data would be successfully implemented if all parts of it were inserted or appended successfully. So hence, the transaction log is keeping track of this. If we only were able to successfully append certain columns of fields, then the transaction log will roll back or undo those changes, because then it leads to inconsistencies and it doesn't make sense to have part of the data but not the other part. Okay, so all of these are to ensure fault tolerance and to keep data consistent. So the other way in which we can ensure fault tolerance and prevent loss of data due to failed disks and so forth is through what we talked about in the previous lecture, disk mirroring, which is implemented through RAID. Okay, and there's different types of RAID when you spoke about this in the previous class. Then we also have the file or the Windows file system. So Windows makes use of NTFS, which stands for New Technology File System. Okay, so it's a new file designed to meet high-end requirements for workstations and servers. It has become a sort of a default file structure for whenever you're configuring an OS on a workstation or on a server. What are its benefits? Okay, when hardware fails, there's still possibility to recover it. Okay, this is through specialized software or through forensics. When you can ensure security, okay, you can ensure security with NTFS through our various access rights and access permissions. We can also compress files, okay? So the operating system is able to compress certain files or certain system files on the computer to make them less in terms of file sizes and optimize the performance of the operating system. NTFS can also ensure encryption. Okay, so files can be encrypted, especially system files, important system files, and also hard and symbolic links, which is another term that we normally use in Linux to refer to shortcuts. So one file can represent another file. Okay, and that's what shortcuts do. They're on your desktop and they are a shortcut to a program or a particular file located somewhere else. So files can reference each other as well. So we have what we call hard and symbolic links, which are called shortcuts in Windows. Okay, so these are some of the benefits of using NTFS. NTFS concepts. So NTFS makes use of the following disk storage concept. So if we say NTFS ensures that there is some sort of recoverability from a failed hard drive, what does that mean? Okay, let's take for instance that HDD that we spoke about in the previous lecture. When we looked at it inside, we saw that there was that actuator arm, which is in charge of repositioning itself to the correct track and the correct segment at which the data is located. So, and we said that the normal hard drive with the spinning mechanism, it cannot withstand shock, which means when that particular hard drive falls or it's bumped, it can malfunction or it can damage the platter. Because remember, the platters are always spinning. Okay, so when it comes to NTFS, data is stored in what we call sectors, clusters, and in volumes. So physically, it's one hard drive physically. But what are sectors? So sectors are the smallest units. Okay, and you can see here, assume that this is one platter. And you can see that the yellow part are the sectors, the smallest units. When we have a collection of sectors, we call that a cluster. Okay, and then you also have our tracks. So the actuator arm is constantly repositioning itself on different tracks, the blue part, to find pieces of data, which is also stored on sectors or a grouping of sectors called clusters. Okay, so also NTFS makes use of volumes. So as much as data is being stored in sectors and clusters, it's also stored in a more generic category called a volume. Volume, it's one hard drive, but it's positioned to be volume A, volume B, volume C, and volume D. And we know that volume C, we have our operating system. Volume D, we have all our music, and volume D and volume C, for example, volume E, we have all our movies or games or whatever. So for this particular for the fact that NTFS uses these particular concepts, it means whenever a hardware fails, because the data is stored in sectors, there is still a possibility to recover it, but you may recover it partially, and when you recover it, it might not work or it might be corrupted. Okay, so you can use specialized software on a damaged hard drive to find the sectors that were not damaged. Okay, and locate files. Maybe the MP3 that you are looking for is stored here on this particular sector. Okay, and this sector is damaged, but you still have parts of the album here and parts of the album here. So you can still recover certain ones, but the damaged portion you cannot recover. So that's why storing data in terms of sectors, clusters, and volumes is actually a good thing that's brought about this NTFS permissions. Okay, and finally, the NTFS volume layout. So how is each NTFS volume laid out? Okay, we have the partition boot sector. It contains information about the volume layout and the file system structures, as well as the startup information and code. Okay, so it contains volume about the partition itself, critical volume, and in some instances, if that volume, like volume C, is containing the operating system, then it's going to contain the operating system itself. Okay, and then we also have the master file table. The master file table contains information about all the different files and directories that have ever existed in our computer. So the people that work with data forensics, okay? So maybe someone commits a crime and they delete certain things from their computer. In terms of forensics, there is something called a master file table, which keeps records that the file did exist. Okay, so somebody denies, no, this file never existed. This particular report, financial reports, never existed on my computer. I've never had access to it. You can actually look in the master file table and it will be logged there as an entry to say that, yes, it was deleted, but it has existed before, okay? And then we have a portion which contains the system files, and then we have the file area, which is the storage allocation or block of storage area, which is located for storing these particular files, okay? So that is Unit 6 on file management and how operating systems handle file management, okay? So we have about just 1 minute left. So if there are any questions or anything urgent that you may need to raise,